Okay, this lesson here is on parabolas. It's our second lesson here in conics. You notice you saw the first lesson on the different types of conics and where they come from. Each next lesson is going to talk about each specific conic, so this first one's going to be on parabolas. Now we have studied this before in the earlier semester, but now we're going to talk about it in relation to other conic sections, and we're talking about a different graphing form. So what we want to do is first talk about what is a parabola. Again, it's a collection of points equidistant from the focus and the directrix. So here we have two key words that we're going to learn, and it's going to be focus and directrix. Now, another thing that we are somewhat familiar with is general form. A lot of times we see this before where we have like the largest degree in front, followed by the smaller degrees, and then a constant at the end. Now notice what here we have an x squared, and over here we have a y squared. And the only difference between these equations is x squared is typically what we see where we think of y is equal to x squared, and we say, what does that look like? Well, that's a vertical parabola. If it was negative, then it goes upside down. So here's positive. When we have y squared, we have the same scenario. If it's positive, it goes sideways to the right, and if it's negative, it goes to the left. Very similar to inverse equations that we saw before. So we see those in general forms. Now what we're going to learn here too is a different form to use graphing, and this is called standard form. And what we have here is we have the squared term on one side, we have the non-squared term on the other side, and notice we have this 4p. This is very similar to the a. It's actually the inverse of the a there. And notice we have an h and a k, so that's our starting point. And we're going to talk about what this 4p means. Okay, so that's what's kind of new to this lesson. So the vertex is simply h comma k, and that's pretty familiar to us. So the vertex again is the bottom of the parabola, and defined by those things. Now notice, being that it's x squared, we know, and that the 4p is positive, we know it's going to go up. We can kind of see that over here. The axis of symmetry, that's the dashed line. It's going to go right down the middle, and that's nothing new. And that is always going to be x, in this case, whoops, x, let's get our pen back here. X is equal to the h value. In this case, goes through the middle of the vertex. The focus is the point also on the axis of symmetry, and it's up here. Now let's talk about up here, scrolling up here. Parabola by definition is all points equidistant from the focus and from the directrix. And what it means is, here we have two separate things. We have this line called the directrix. So I'm going to dash that in here. And that is right here. And I'm just going to label that the directrix, just abbreviate it. And what it means is, you do a different color here. If we have a point on the line, it is the same distance from the focus and from this dashed line of directrix. Those two things are equal. So if this is x, then that's x. Okay. This point up here, if this distance here is y, then this distance here is y. Those are equal. Okay. This is like why flash bulbs work and alike, and we've seen that before as well. Okay. So we have to define that focus, and what we have here is it is P. I'm just going to put it, I'm not going to put like an order pair here. It's going to be P distance away. And what P is, we call that the focal distance. Okay. And I'm going to do it in a different color here. We'll do it in blue. The distance from the vertex to the focus, and again, this is the focus, and that little distance is called P. Okay. That same distance is from the focus, from the vertex down to the directrix. That's also a distance of P. Okay, so the directrix here, notice, is going to be, y, y is equal to, again, I'm going to use p-value from vertex. Okay. And again, these are just kind of general. We'll see better examples when we actually see some numbers in here. But what we want to focus on is that P is this riding distance, and that P, notice, is derived in the equation right there. So let's go ahead and take a look here at how the horizontal difference. Now notice here we have a y squared. So now we're talking about a horizontal type of parabola. And notice notice the x value is to the single degree. So when we see y squared is equal to x, that tells us horizontal going to the right. So the vertex once again is now h comma k. The axis of symmetry now, notice, goes horizontal. So it's going to be y equals whatever the k value is. Okay? And then the focus, here's your vertex, here's the focus, so I'm just going to label them. And then we have the vertex right here. And then I'll do a different color here for the directrix, which is now a vertical line. So the directrix in this case would be x equals, and again, you put in the value there. And again, both the focus and the directrix are p distance away. Okay, so I'm just going to put a little note there for that. So let's go ahead and see how these look like in using numbers. So looking at the first thing, here we have standard form. So the first thing you want to look for is that notice that the x squared is positive. So here we have a vertical type of parabola. So let's take a look at where's the directrix. I'm sorry, the vertex. We're going to have 4 comma negative 1. So there's your h and k. Notice they're inside parentheses. So I take the opposite value of both of them. Okay. So first I'm going to go ahead and graph that point over 4, down 1, and label it right there. Okay. Axis of symmetry. Now again, this is vertical, so I'm going to go ahead and draw my dashed line right away. I want to get these down right away so I don't get confused on what's what. Okay, and that's going to simply be x is equal to 4 because it's a vertical line going through the vertex. Now the focus, we have to find p. So what I'm going to do is, I'll do this in a different color, is I'm going to highlight this value here, and I'm going to set that value equal to 4p. And if you solve for p, notice p is 2. So knowing that the parabola goes up and down, I'm going to go up 2 and put a dot, and that's my focus. And I'm going to go down 2 and put a dot, and that's my directrix. So I'm going to go ahead and do a dashed line through here. Okay. Now, just looking at the graph, I can go ahead and say directrix is simply y is equal to, and just look at the graph, I went down 1, 2, 3 spots. So I'll go, excuse me, go down, oh, go down I lost my pen here. Go down -3, and y is equal to -3. Now, how do we know how to draw the width of the curve? We have this thing called focal width. Okay, so let's take a look at the focus. Again, I'm going to look at the graph here and so you notice that it's simply over 4 and up 1. So I'm going to go over 4, up 1, just right as an ordered pair. The focal width is always equal to 4p. Okay, and what that means, it's the width of the parabola through the focus. So here is the focus, and if the width 4p, which is 8, I'm going to go over, whoops, undo that. I'm going to go over simply 4 this way, put a dot. I'm going to go 4 this way and put a dot. And notice from this dot to this dot, it's a total of 8 wide, which is 4p. And that tells us the width or the scale of the parabola. So now I can go ahead and sketch my curve in and bring it down like this. Go down through the vertex, back up through the focal width, and we have our curve. So really the red line down here, the directrix and the red dot are not a part of the curve, but they help guide us to where the curve is. So if this was a flashlight, you would actually put the bulb right here at the red dot, and that way you would have parallel lines coming out of the reflector here. Okay, let's go ahead and take a look at another example. So notice this one here is y squared. So when I see this, I see y squared, and notice that it's positive, so that means the curve is going to go to the right. So what's my focus, or my vertex, I'm sorry. Now I'm going to start with the x value. So I'm going to go -2, because you take the opposite value, and then I would go +4. So there's our starting point, -2, comma 4. So I'm going to go over 2, up 4, and there's my point. Now again, we know our curve is going to go this way. So, if I was just to sketch in roughly, it's going to go like this and go like this. I'll just leave that there for right now so we have a reference. So let's go ahead and now put in our focus. Again, let's I guess maybe first be better to put in our axis of symmetry, follow suit here. So we go ahead, draw our dashed line through, And again, that's y equals 1, 2, 3, 4. So we simply say y is equal to 4. I'm just looking at the graph to get this information. In the focus, again, we're going to look at 7. So I'm going to set that equal to, we'll do this in a different color, 7 is equal to 4p, and simply 7/4 is equal to p. Okay, so our focus is 7/4 to the right, and then 7/4 to the left for the directrix. So 7/4 is just shy of 2. So I'm going to go over almost 2 and put a dot, and that's my focus. I'm going to go almost over 2, again, 7/4 to the left, put a dot, and then draw and sketch in my directrix through that point. So I'm just going to sketch that down. So right there, I can say, okay, what is my directrix? It's x equals, okay? And again, if I started at -2 and went over -3, 3 3/4, I can just write it like that, -3 3/4. Again, I'm just referring to the graph to get at that information. Or we could say -2 minus 7/4 and get the same thing. Again, the focal width is total of 7. Okay, so from our, whoops, that was my hand again. From the focus, I'm going to go up 3.5 and down 3.5. So I'm going to go up 1, 2, 3.5, and I go down 1, 2, 3.5, and that gives our curve. So what I'm going to do is go ahead, I'm going to get these curves all the way. Again, I just use those as reference points, so I'm just going to throw those off to the side, don't need any more. And now I'm going to go back in and draw my curve. It's going to go through the vertex, through my focal width, and again, that gives me an idea of how wide the scale is of the curve. And again, when I talk about this focal width, if I highlight it, notice the distance from this point to this point is a total of 7 wide. So that's what we're looking for. So the focus here, again, is we started at -2 and we went over 7/4. We're 1/4 away from 0. So I'm going to simply say -1/4, comma 0. I'm sorry, comma 4. Let's go ahead and erase that there. Put the wrong number down. And we're going to put 4 right here. And that is our focus. So the things we want to pick up is vertex is key, focus is key, the line through the middle is key, the directrix is key, and the focal width key. So these are the 4 key elements that we're looking at in doing these items. What I want you to do is go ahead and take a look here. I'll go ahead and get you started for a couple pointers. What I want you to look at is notice that we have x squared, but notice it's -12. So what we're going to have is a parabola that's going upside down. Okay, so use that information to find the vertex and the other information. And let's go ahead and have you try this element here.